Thank you for joining me today for the Lunch and Learn. I'm going to talk about caching, persisting, and views in Databricks. And those three things, they're really helpful for if you're using a data frame a number of times in a single session. Caching kind of saves your data frame in a way, and persisting does the same thing, sort of. And then views kind of store a query. So they're another way of sort of saving something about your data if you want to use that exact sort of data frame a number of times in a single session. The learning objectives for today are to understand what cache and persist actually store, when they improve performance, what do they do, what is it, to understand how temporary views relate to underlying data frames and SQL queries. So what is happening when you do a temporary view and when is that helpful? And then also to identify when those things are appropriate to use. The other thing for this topic is also to understand, when one of the reasons that we have this topic is because it's something that's recommended to people a lot. So if you've ever used Chat AI, it may have recommended that you use cache or persist in your code that you may have shared with it. And it's really important for you to understand when it's appropriate to take advice like that from the chat, and to understand if that advice is good or not, because that's always on us to make sure that whatever we hear is correct. So this presentation should hopefully help you to gauge that, since the chat doesn't know our environment or what if our data are large or small, or the format, any kind of stuff like that. It doesn't know context like you do. So here are a couple of the functions that are related to today's topic. You'll see these: the df.persist, df.cache, and df.create or replace temp view, and then whatever the name of the view is that you want. We've covered this in other presentations, but I did want to talk at least a little bit about what's happening under the hood with your data frame. And also, I'm going to talk a little bit about your cluster. So I'm just going to skim this. There are other presentations that we've done that talk about these things in a little more detail. But the reason that these things are important is because cache and the views are not going to necessarily help you if your code is not taking advantage of all that Spark has to offer, and if your code's not kind of structured in a way that it can be distributed, lazily evaluated, and all that kind of stuff. So Spark is lazily evaluated. Here, I have a little simple diagram that shows at the very top you have a data frame of some kind, and you want to do different things to it. You may tell Spark, okay, I want to do a filter on this, a select, a group by. I need to join a couple other tables on here, and then I want to create new columns. You may have all these different things that you're doing to it. It creates that to-do list. You're basically giving it a to-do list that it saves and sits on. And that to-do list is called the execution plan. And it does not do anything that's on the execution plan until you do some kind of action call. So that could be display, count, show, take. If you want to write something to S3, those things will all trigger your execution plan to happen on your data frame. So the other thing is that Spark data frames are distributed. And this is important especially for the caching, because what caching does is it's a way to kind of save your data frame that you're working on in memory, so that you're telling Spark, this data frame is important. I want you to keep it ready to go. So it will save it in each of the worker nodes. It's not saving the whole thing. Your data frame is distributed because you're taking advantage of all Spark has to offer. So your data frame is in partitions. And then those partitions are saved each to some kind of worker node. And then caching allows it to stay there and be ready to use. So if you have something that is large and something that is expensive to create, your data frame, if it has a lot of joins, a lot of columns created, maybe you have some window functions. If it's complicated to create and it's large, that can be a situation where you will find caching helpful. But caching and persisting, I imagine these are going to be pretty rare that you'll be actually using this. But there are situations where it could be helpful. And not only does your data frame need to be kind of large and expensive, but you will want to be using it more than one time to make it worth considering this. So the thing about your compute that I wanted to mention, so here's my cluster that I have defined. I have more than one. So I have it, I let it give the name, the default that it does for all of us. And then I added Databricks runtime 16.4, Scala 2.12, and then I kept the cluster in there. That's fine. But the thing I wanted to mention about your cluster is keeping in mind that it's not just one thing. You have your driver node and you have worker nodes, and we're allowed up to 30. They have a certain available memory of their own. These have 8 gigs available to them. And then you have some amount of memory, disk space available also. I'm not 100% sure that we have that available to us in this environment, but I don't think that may not be as useful to you guys as just working with something in memory. So that 8 gigs that you see here for this large one, the XL, I think is 16, and then there may be a few compute policies that allow larger, like the jobs or things like that. But just this is something to keep in mind, that this cluster, it's not one thing, it's a driver, and it spins up other instances of workers that get to do things to each of the partitions of your data frames in memory in parallel at the same time. So that's something I just want you to keep in mind as we're talking about this, because all the things that we're talking about today, the best way for you to get a good efficiency out of your program or your notebook is to make sure that your code is scalable, that you're taking advantage of these things and thinking about all of this as you're setting up your code. You want to be able to know, what do I need to do and when do I need to do it? When is it appropriate to bring in all the different data sources that I'm working on? Because if we're working on a notebook that's kind of small or maybe not super complex, so you have a few data sources and some imports, and maybe you organize them where you have, everything kind of up top, and then you do all of your operations, and then maybe you do some of your actions toward the bottom, and that can be fine if it's something that has just a few things. But if you have a really big project, like I know a lot of you do, where you bring in a lot of different data sources together, sometimes that can be too much to bring in all at one time. So you have to know when to bring in the different data sources at the different times, because you don't need to bring everything all in up front. You may just bring in one thing up front and then a few things coming in the middle. And I know that can be kind of more difficult to keep track of, but that's a topic for another day. Just remembering that bringing things in at the appropriate time is still important for this caching and persisting. So like I said before, this can save your data frame to memory or disk, and caching just does memory. So that's why I'm focusing on that mostly. So if you have a data frame that you use multiple times without changing it, maybe have multiple group bys or counts. If you're doing different visualizations with the same data frame, so you get it to a certain state, and in that state, you want to do a bunch of different things to it, that caching could be helpful to save you time and compute resources. And if you're doing multiple analyses on the same thing, if you have a training data set that you're doing a bunch of things on, those are the kind of situations where you'd be using a data frame multiple times. But again, that data frame may need to be pretty large and complicated to create in order for this to, for the juice to be worth the squeeze for you. So where would this caching fit into that initial diagram that we made, where we said, okay, I've got my data frame. I tell it I have all these transformations I want to do, a filter, a select, whatever, joins, and it creates that execution plan, that to-do list for Spark. And then after that, after you get your transformations in order and to the point where you want that data frame to be kind of saved and marked as special, you would call cache before you do all of your action calls. And when you call cache, it is not automatically doing that action until you call something like count or show or take. And that I'll show you what that looks like next. And first of all, as you see right here, not caching is probably going to be the fastest way for you to get efficiency out of your data, but in a few cases, this can help you. But for the most part, the most important thing is to make sure your code is scalable and making sure your data frames are distributed and that you're not calling things into just the one node and that kind of thing. But for example, this data set is not one that I would cache, but since we all have access to this, it's all in no PII, it's appropriate to share. That's why we're using this, but this is not a good example of one you would cache, especially since I'm not even doing anything to it. But even if I did do as complicated as I could get with this, I probably still wouldn't need to cache it. But if I wanted to cache something, I would have my data frame dot cache and then dot count. So that count will trigger the cache to occur. So it will save that in memory. Spark, you're telling Spark, this data frame is important and I want you to keep it here in memory. Don't delete it. Don't garbage collect it. Don't set it aside to recompute later. I want it ready to go. And then you'll need to make sure to tell it when you're ready to, when it's not important anymore, when you don't want to save it anymore. So this is telling it, this is important, save this for me, please. And this code, so persist offers you more storage level options, so that when I was talking about saving things to disk and memory and disk together, that kind of stuff, that would be where persist comes in. I'm not going to talk too much about that because I really don't think I don't think it'll be helpful for the projects that are working on in our environment, but if it could be, I could be wrong. So persist storage level dot memory only, that's the same as just saying dot cache. And then I have to call count on it to trigger this to happen. I'm still reading in that same data frame as before. And for this, you have to import this storage level, this storage level object. And then you specify what level you want. And then just as an example to show you, you want to do other things. You don't just want to cache it one time, and it's not going to help you do anything if you don't use it multiple times. So here are some multiple just, random stuff to do with that data frame. And then you need to unpersist to clear that. You can also go up here to run and say clear state, and then that will also uncache. But it's good practice to make sure that you put it in your notebook so you don't forget this step. So for some sort of, good idea, bad idea situation, here is an idea this is not a good idea. If I have something that I'm doing to pandas, my code is no longer scalable. It's all gone back into the driver node. It's in one place. It's not distributed anymore. So then I'm losing a lot of the advantages that Spark has, especially if my data frame is large where we want to be using Spark, which in our environment, that's most things. And then to use cache, I would have to bring it back in. Let's say I do pandas, I do some stuff, I bring it back in here, and then I do cache because I think, oh, maybe this will help me save some time because my code, I'm having trouble with it. It's taking a long time, running out of memory errors. And then you have, some other lines of code here, you unpersist, but the caching is not going to save you or help you if you are doing things that are inefficient, that are not kind of best practices. And when I say I want you to make sure that your code is distributed and in good shape and efficient before you try caching, it doesn't have to be the most perfect code anybody's ever seen. Just make sure that you're, following best practices and that you're, doing the best you can to make things kind of efficient before you think about trying this in your use cases. So here's maybe a good idea. So instead of doing, you know, maybe I want to get my data frame all set up like this. I read in something, I'm filtering, I'm just selecting what I need, and then I have, you know, a couple of recodes. And imagine I'm doing more complicated things that I'm adding to this to make it a really actually good idea. Then I want to cache. And here I'm using take 5 instead of count. There was a Databricks forum post where somebody suggested that you can use this instead of count, and it's actually more efficient because this take 5, it just grabs like, I don't know, the top 5 rows. And this will complain if you try to display it, but it prints out okay down here. Because this is not a data frame object. This is just a list of row objects that it spits out for take 5. But it just kind of depends on what are you doing in the follow-on steps. Because I tried it with a few examples. I tried to get as much data together as I could to make it to get a good example of caching with a lot of rows. And there were a couple where I had maybe like more than 300 million rows that I could kind of make it save a little bit of time maybe. But comparing the take and the count, the take did save time when I had a really big data frame. And even that even saved time when I wanted to also do a count. So it was kind of funny that worked out that way. But using take 5, if you do try to do caching, you may want to trigger the cache with this and try and see if that saves you any time. So then, you know, we have our cache data frame, and then we do some different stuff. Maybe I have some order counts by the groups. I do these different things. I check my recode. Maybe I make some kind of 2x2 table and, you know, do a bunch of different things with it. And then when I'm done doing all that stuff, using my cache data frame over and over again, then I want to unpersist it. And then it'll just tell you, okay, this data frame just return some information about your data frame. And that is to cover caching. So the next thing I'm going to talk about is the views, because that's one thing that I know a lot of us like to use this as kind of an intermediate step to check our data and everything. And that's fine. But to understand, views will store a query. They don't store any kind of data, and they will compute that view each time you call it. So if I save a view and then I want to use it later, it's going to have to redo that query that is happening under the hood to create your view. And a nice thing about this is if you I recommend using create or replace instead of just create your view. That does not interrupt your execution plan. So if you put it in between, in the middle of stuff, so let's say I have a data frame and I want to do a few things, and then I have a view that I want to check later to make sure that my data look okay. You still have to check it in the same notebook session, since we don't have access to like a saved view in our environment. The create or replace view, you can put it in the middle and it's not going to cause some kind of action to occur that will compute everything up to that point until you want to call your view. So it's just another tool that you have that I know a lot of you like to use, but just remember it will compute every time it's called. So here's maybe a bad idea. This actually, I'm going to show you 2 code blocks. So here's this code block. It's kind of long. I'm using a couple of views in here, and then I'm creating them, and then I'm actually using them to calculate a next step. And I'm calling this a bad idea, not because it is, you know, better and more efficient than this, for example. So this is the exact same thing. It's just all in PySpark, and it's all together in one call. But this runs a little faster than this. And the only reason I'm calling it a bad idea is because it's a little harder to maintain this and look at this and read this and know exactly what's happening than if you just had this, which is simpler. And I know I've told, you know, probably some of you before that SQL Databricks is optimizes SQL very well, and so the more that you can push to like a spark.sql query up here, like so if I put all of this into a query up here with spark.sql, that can save you time and compute and stuff, and it can optimize it better sometimes. But like this is totally acceptable also, and it can be pretty fast. It's just all about managing your execution plan, making sure things are distributed and all that. So here and it also, the execution plan for this and the below look the same. So it's not interrupting the execution plan to create these views and even to use them. But I think the below is a lot easier to maintain than this is, but I know some of you have things where the code like kind of necessitates you having the SQL here as a follow-up. And that's okay. I'm just kind of showing you the two next to each other, and that PySpark code did run a little faster, and I think it's easier to maintain. So here's another idea for a view. So if you have you go up to, instead of including a group by count and ordering them, which is what we're doing up here and at SQL above, I'm going to cut it at the with column. So instead of doing the group by and the calculating things that I want to do with this, in here, maybe I create a data frame and I use this multiple times. So instead of just using this one time, I'm going to do a bunch of stuff with it. Maybe I want to create a view to explore or something like that. And so then you create it on that part of the data frame that you're creating. And then you might do a bunch of other stuff, group bys, order by, and things like that. So in conclusion, the caching and temp views are good tools to kind of keep in mind if you're have a data frame that you want to use multiple times in a single session in your notebook. Caching can be useful if you have something large and it's complex and you're using it multiple times. The temp views are stored. They're calculated when they're called, so it may be something that you want to do to something multiple times. And then I wanted to make this point again, keeping your code scalable and the data frames distributed is that #1 defense against getting out of memory errors and having slow code and things like that. So the caching is probably rare. The temp views are a really nice tool to use, for things. But yeah, make sure to keep your things distributed. And I have a bunch of links below that I hope you can check out and find helpful. And I hope you found that helpful. I'll turn it back over to Julia. Oh, sorry. I believe that they are available in Sparkly R too. And if you don't unpersist, does it automatically unpersist after the cluster is detached? Yeah, it will. So if you clear the state of your cluster, or if you terminate it, or it terminates on its own, or you restart the cluster, that will also get rid of your cache in there. And then the storage levels for persist, let me go back up because there is, actually I might have it down here. Oh, I have it right here. Okay, so there's memory only, that's the default. It puts that in that memory, so that 8 gigs here that I have, or if you have the extra large, it'll be 16. The partitions, it will fit what it can on the worker node. And if it has multiple partitions on a node, because sometimes that happens because your data are just not that big, or they're not big enough to have it that way, it will recompute anything that does not fit in memory, but you will still very likely run into out of memory errors if that kind of thing happens. Memory and disk is if there's something that doesn't fit in that 8 gigs, it will store it on disk, which I'm not 100% sure we have available to us. And then disk only is useful if you have something that's really big and the partitions are really big. and it will, I think we get like 70 gigs maybe on these M5DN. Don't quote me on that, but the AWS does have, if you search M5DN, AWS, or Databricks, it'll send you the same place. That will give you, an idea of how much space there is, but that includes like whatever Spark needs to be installed on each worker node, and Databricks installs stuff, and Databricks has different things that it stores on the disk that, may or may not be related to what you're doing, but it still takes up room. So that's something to think about.